Hi, this is Bruce at Big Rig Tech. Today, I'd like to do a quick, easy activity to illustrate how resistors are used in sensor circuits in vehicles. Um, what I've done is I've taken a pencil and drawn a box on a piece of paper and colored it in. I've shaded it in. Um, I've gone over it several times to make sure it's nice and dense and consistent. I use just a regular mechanical pencil. They seem to have nice soft lead and they seem to work pretty well. Now this rectangle I made, this resistor I made, happens to be 14 centimeters by 1 centimeter. It's kind of a convenient size. So I'm going to mark this off in increments so that I can see what the properties of my resistor are. 14 centimeters, there's the halfway point, and 0. So let's take some readings. These days what you want to use is a digital multimeter. I paid $20 for this one. It's got several scales. It'll read voltage, both AC and DC. It's got a diode tester, continuity tester, an amperage, and of course it reads ohms or resistance. So let's set our resistance. This doesn't have auto ranging. Auto ranging is a nice feature. You can just put your probes down on a circuit and it'll automatically set the range for you. But it's a couple bucks more for an auto ranging meter. So I'll just set it and put my probes down, and if I don't get a reading, then I know I need to change the scale. So let's try it here end to end. I've got 52 ohms from one end to the other. And let's see what we have in the center. I have 27, so that's pretty good. 27 is about half of 52, so that looks pretty linear. Now let's take these intermediate readings. I've got 40 ohms, and I have 16 ohms. So I'm pretty consistent, 12 and 11. Pretty consistent, pretty good. But what's really interesting is when you put a power source through this resistor, and that really illustrates what resistors are for. This is a AA battery. Nominally they're 1.5 volts. This one's been used a little, so we'll check the voltage on it. And we have 1.4 volts. So let's use this power source on our resistor and see what it does. I'm going to take the positive end and I'll put that on one end of my resistor, one probe on the other end of the battery, and we'll go down to the end and see what kind of voltage we have left. We have 1.34 volts left down here. So let's go to the center and see what we have. And we have 1.38 volts. And here we have 1.36. And we have more here, 1.39. So that's interesting. The farther we get down the resistor, the less voltage is left, which makes sense. More resistance, less voltage. So if this were a resistor in a fuel tank sender, the old style fuel tank senders had a swing arm with a float on one end that followed the fuel level, and the other end went against a resistor, and each point on here would correspond to a fuel level then. A throttle position sensor would have an input voltage, and then as you push down the throttle, it would move across a resistor and give you a varying resistance and hence a varying voltage coming from the output. Most of your sensors run on a 5-volt reference. So the computer inputs 5 volts to each sensor and then reads what comes back through the sensor and infers a fuel level or a pressure or a throttle position from that voltage. Basically, that's all there is today for this little activity. Visit Big Rig Tech for more information like this, and visit often. Thank you.